So obviously on the bench are a set of Atari 2600 paddles. I'm actually using these with my Atari 800 to play Super Breakout. The Player 1 paddle works absolutely fine, so everything is fine with it. I don't know which one is 1 and 2, but the Player 2 paddle, the pot's dirty. And so as you rotate the knob, the paddle in Breakout just skitters around and jumps, and it's really, it's got really poor control, and that's just the wiper inside of the potentiometer on one of these is dirty. So I'm going to go ahead and pull them both down and clean them. So as you saw there, you can pull the knob right off. It's got a half moon shape inside. The post, if you can see, it's half moon shaped. You just line the half moon up, push it back on. Don't force it. They should come off reasonably easy. It really is just a standard potentiometer in there. I have not been inside of one of these for decades. Matter of fact, I think it was my 2600 way back, wow, it was a lot of years ago, that I actually had to open up and service a pot in one of these. So I don't really remember what's inside. So there's obviously a push button switch here. Looks like it's just a standard, really, keyboard. It's a keyboard switch that the little red goes onto, and it becomes, okay, have I already done something stupid? Already done something stupid, can't get it to now work correctly. It had to have been in that direction. There's no alignment on that, so I'm really, let's get the clamshell back together. Now it seems fine. Anyhow, what we're actually after is the potentiometer here, and you can see there's two leads soldered to it. And what the potentiometer does is it's got a carbon pad, so it's a 1 mega ohm resistor. Let's actually draw a little bit of this out, talk about what's inside of there. So there's I'm going to use red here because it's the pin that came up. Color doesn't matter here. So inside of the pot, I'll attempt to draw it here. Is a carbon ring, and there are two pins connected to it, and this is a 1 mega ohm pot. So these two pins would represent the two outside contacts here, and if you were to measure the resistance between those, it should be about a mega ohm. Then in the center, you've got the shaft that rotates, and that third lead comes in and is connected to a wiper. And as you rotate the potentiometer, this wiper runs around. And so if the wiper's all the way down here at 0 ohms, 250K, 500K, 750K, and the 1 meg again. And so it creates a variable resistor. And really, it depends on the position of this wiper. As you rotate the knob, like I said, this wiper will rotate. And the resistance will change. And that's how the Atari is determining the position, say the paddle in the game. Well, if this wiper can be, the surface of the carbon here can become dirty, the wiper can become dirty, and what happens then is that as you move it, the little wiper makes and breaks contact, and that causes the jerkiness. So what we really want to do is get some contact cleaner in there. I prefer actually using contact cleaner. You can find different brands. I've got some Deoxid here, contact cleaner, Deoxid, from GC Electronics. There's a lot of brands. You can find this on Amazon. It's not horribly expensive. It's really good for cleaning inside of switches and potentiometers, edge connectors. If you watch Adrian's lab, Adrian's Digital Basement, I think it is, he uses contact cleaner even in IC sockets. He's really liberal with it, which is fine. But like, an edge connector in my Atari 800 and a cartridge, if I had trouble, I could spray the cartridge, gold pins, maybe even spray down into the connector and then just put the socket in out a few times. But the idea is to squirt this in and then to actually work the shaft, so to wipe it back and forth several times. So on a typical pot like this one, there's a notch punched into it like you see right here, and that notch is what keeps the shaft from rotating all the way around. It'll actually hit up against that notch, but what that notch actually gives us is one place we can get cleaning fluid into it. On this pot, there's actually a large gap down in here we can get cleaning fluid in through as well. I'm going to tilt it up, and I'm just going to spray this in there liberally. And the other thing contact cleaner does is it lubricates. So I'm turning it full rotation end to end. It's not going to hurt to give it a second shot. It's plastic safe. It won't dissolve the plastics. It definitely has it produces fumes. You know, there's definitely something in it that evaporates out. It's safe to leave on. You don't need to come back behind it with like alcohol and clean it out. Now I've got a little puddle down inside, and I do want to clean that little puddle out. There's no reason to have that in there. That's just because I sprayed in the end way too much. It's not going to hurt to be inside of there. We should be able to set the switch back in place. It was there. There was the cable back down into the strain relief. We'll put this one back together. Why that solvent is smelly. And you may have heard the little pop as it dropped into the original threads. You see me harp on this literally in every video when I do, and I apologize for it. Make it a habit. There it was. Make it a habit. Save those plastic shafts. Sucks when the screws become so loose you can't tighten the case up. That's nice and smooth. No problem with that at all. I don't know if that was the bad one or not, but since we're here, we're going to do both. There's no reason not to. Don't think that screw had ever been out based on that little pop. I'm amazed actually at how good a condition a lot of this stuff is, considering the age. It's really interesting. Again, it's a keyboard switch, but we're just going to do the same thing. Give it a good shot and rotate. It would actually be easier to rotate if I left the knob on, but I didn't. You know, if you need deep clean, then the knob will come off and make it easier to clean as well. Potentiometers do go bad. It's quite possible to replace a potentiometer in one of these if you needed to. It happens. It's fairly rare. Although it does happen. Heavily used paddles, I wouldn't be surprised to see pot needing to be replaced. I've also, over the years, actually opened up a potentiometer like this. There's little bend tabs you can bend back out of the way, and then actually open the mechanism up, and you can see inside. And the little wiper here has got some springiness to it, and I've bent those again to increase that springiness, taken an eraser to the carbon, and cleaned it up and recovered the pot. You know, got it working well again. So that's another possibility. It's just, you know, whether you're inclined to want to tear it apart, an attempt to put it back together with the chance you may never get it back together. I'm sure you could find a very equivalent pot on DigiKey or Mouser or any one of those kind of sites. I'm happy with that. Why does that not feel like it's going together okay over here? How does that actually go in there? Is there... Okay, there is a orientation it goes in. The rounded part is down like that. There we go. It snapped back in. And then the flat part in the strain relief molding mates up against the flat there. So that feels better. Oops, there we go. Definitely feels looser to me, which it should, because they're lubricated again. So, nope, very happy with that. So that's really it. Not a whole lot else to cover here. I guess thanks for watching, and I'll see you in a future video.